So first of all, we will study about the straight channels and then meandering and at the last braided channels. So straight channels are the channels which we are well familiar and we have also studied in our physical life, and we are well familiar. I mean, in our life we have studied in different forms, just like canals, and sometimes we also studied in the rivers. Rivers may also in the form of straight channel at some extent, so they are not from initial point to final point in the straight channel. Anyhow, at some locations they are the straight. So in straight channels, the sinuosity varies from 1 to 1.05. What is sinuosity? Sinuosity will be okay. Next one is the meandering channel. Follow the sinuosity. It doesn't have any specific path. It changes with the passage of time, because the channel contains the bank of the channel are not enough uh, strong to retain that water, and many factors causes to change its direction. So we will also study in detail about metering channel, how they change their direction, and how the which values are the sensitivity values for the metering channel. So last one will be the braided channels, in which we will also study its detail, and the definition is channel flows in more than one sub channel. There is no one specific path, so it may be a number of paths that it follows to move from upstream to downstream, because its naturally topograph does not match the hydraulic conditions of the river. So we'll study it in detail in the next slides. So first of all, what is the sinuosity? Sinuosity, the meandering ratio or sinuosity index is the ratio of actual length along a meandering river to the straight distance. So here is the clear definition of sinuosity, that the actual distance from first one point to another point divided with the ratio of the actual length. Mean actual length is that is LM. Okay, actual length is the LM. Mean from this point to this point, it covers the distance actually it has. मीन के जो इसके पास ओरिजिनल डिस्टेंस है, original distance in different form of waves ये cover करता है, that is the actual distance. And the next part is straight distance. So here is a straight distance we have mentioned with the LC. So the actual distance and the problem student. Okay, so it is the sinuosity is the ratio between the actual length to the straight distance from that point to the next point. So from this wavelength, you can easily observe the value definition of the sinuosity. So in meandering channels, it has different values. It may be the length of the wavelength may be larger, or it may be lesser. So it depends upon the location, and it depends upon the that type of the sand that it passes through that material. So it's have different values for the different meandering channels. So sinuosity is the ratio between the actual length to the along the meandering river to the straight distance as between the endpoints, that is AB. About these points, endpoints mean those points which you are observing or you are studying. It is the indication of the quantification of the meandering for a straight over river courses. This ratio is equal to unity. Okay, so for the if you have a straight channel, then the value of sinuosity will be equal to 1. Can any student tell me about how it is possible that its value is 1? इसका इसका कैसे यूनिटी हो सकता है, बच्चा बता सकता है इसमें? Let's make some discussion. साथ साथ ये नहीं सिर्फ पढ़ाना, there should be some discussion. बोले in the straight channels the value of sinuosity will be unity. Is it possible or not?
Yes sir.
Okay.
Yes sir.
कैसे कैसे बोले?
अरुण
सर
दोनों
कार
में जो
पाथ
एक्चुअल
तो है नहीं, स्ट्रेट पाथ ही सेम है।
यस ठीक है, शुक्र है कुछ बच्चे जाग गए। Okay, so ratio varying from 1 to 1.5 defines the river course as meanders and from 1.5 to meander. Okay, so meandering values vary from 1.5 to 4. So when you will study or you in your study case, then you will observe the different values ranges from 1.5 to 4. Here is the curve or wavelength in which it is the top view or plan view of the hindering channel in which from the initial point is A and the end point is B, and in which W is the width of the channel, and it also vary from location to location, because I have also told you that the banks of these mineral river are very weak. So due to erosion process, its direction vary with the passage of time. So there are many techniques that are being used to counter these erosion or to counter these mirroring process. So we will not study about that techniques that are being used in our research field, that how to counter the erosion or how to resist these mirroring process, either it is favorable or not. What do you think about that? ये जो हमारी ये mirroring है, is it favorable or not? It has positive impacts or negative impacts. बोले बच्चे, what do you think about it? It should be or it should not be? बोले बच्चे,
सर इरोजन ज्यादा नहीं होनी चाहिए क्योंकि पाथ वो कर रहा है, मींडरिंग बेल्ट है ये।
you are thinking that it should be mean कि there should be erosion.
यस सर।
क्यों क्यों erosion होनी चाहिए? क्यों ये अपना पाथ जो है ना वो वेरी करे, क्यों चेंज करे? बोला है ठीक है, जस्ट लाइक ये डिस्कशन
सर
है, इट इज
टोपोग्राफी का
लर्निंग
भी
लर्निंग लेक्चर। बोले
सर टोपोग्राफी का भी इफेक्ट होता है।
होता है, डेफिनेटली होता है। तो क्या इसका इम्पैक्ट नेगेटिव होगा या मीन के फॉर द इन्वायरमेंटल पॉइंट ऑफ व्यू से अगर हम इसको देखें तो ये हमारे लिए प्लस पॉइंट है, ये नेगेटिव पॉइंट है कि अपना ये रास्ता किसी टाइम भी चेंज कर ले?
सर नेगेटिव इम्पैक्ट ही हुआ।
नेगेटिव इम्पैक्ट ही हुआ ना बच्चे, क्योंकि अ, जहाँ पे भी मिररिंग होती है तो इरोजन ऑलवेज हैव नेगेटिव इम्पैक्ट। जो इरोजन का प्रोसेस है, इट हैज ऑलवेज नेगेटिव इम्पैक्ट। सो a
यस
lot of
सर।
techniques are being used in the research field कि कैसे हमने इसको काउंटर करना है टू resist against the erosion। तो इरोजन की वजह से a lot of problems we have to face। so मिनरिंग की वजह से नेगेटिव इम्पैक्ट्स ही पड़ते हैं विद रिस्पेक्ट टू इन्वायरमेंटल पॉइंट ऑफ व्यू। ओके, तो इन्वायरमेंटल के हिसाब से इसके नेगेटिव इम्पैक्ट पड़ते हैं। सो वी हैव टू काउंटर द मिनरिंग, बिकॉज अब यहाँ पे अगर देखें ना तो जो इसका डिस्टेंस, इट शुड बी LC फ्रॉम दिस पॉइंट टू दिस पॉइंट। ये अगर इतना ज्यादा डिस्टेंस कवर करता है तो इट मीन्स दैट इट कवर्स दैट एरिया, इट इज वेस्टिंग दैट एरिया दैट शुड नॉट बी हमारे किसी काम का नहीं है। मीन कि अगर हम एनवायरमेंटल पॉइंट ऑफ व्यू से देखें तो इट शुड बी स्ट्रेट, नॉट मींडर। Anyhow, at some locations we cannot make straight because of natural phenomena, क्योंकि ये एक natural phenomena है, और it also depends upon the soil that above it is flowing। मीन की जो soil होती है, sometimes ये भी होता है कि जो soil है, it is very favorable for the erosion। So we cannot make any or we cannot apply any techniques to resist or to counter these erosion। So we are हम इसमें मीन के अपनी कोई भी टेक्निक यूज कर लें, and this is because this is a natural phenomenon, then it will mostly happen। Okay, so here are the straight channels, and the meandering channels and the braided channels. So here in this picture, you can see that here some structures are also applied, just like these. अगर मैं यहाँ पे शो कर सकूं, अगर आपको मेरा कर्सर नजर आ रहा है, तो these are some structures. Can any student tell me about these structures? What are these structures and why they are provided?
सर ये इरोजन से बचाने के लिए जो किनारे होते हैं, बैंक्स वगैरह।
क्या होते हैं इनको, हम क्या बोलते हैं?
स्पर्स कितनी है कुछ?
सर रिटेनिंग वॉल्स ही होती क्या? सर आइडिया
No,
नहीं है, रिटेनिंग वॉल ही होगी।
no,
जे
it's
स्पर्स
not written. Yes, yes, these are known as spurs. Okay, well, very good. So what is their purpose? Why we applied these spurs on the banks?
वाटर
ये
वेलोसिटी
वाटर की
रिड्यूस करने
ट्रेनिंग
के लिए।
के लिए काम आते हैं
Water.
सर। वाटर ट्रेनिंग समथिंग पढ़ा था इस तरह का कुछ।
Yes,
वाटर
definitely.
वेलोसिटी।
Water trainings. These are the water training structures. Okay. If you have studied about these, you can also tell about other plus points. इसका कोई और तो फायदा होगा ना, सिर्फ ये नहीं कि river training structures. These are also provided to save the embankments from the erosion. अगर आप यहाँ पे देखें तो जहाँ पे भी ये स्पर्स, इनको स्पर्स भी बोलते हैं, स्पर्डाइक्स भी बोलते हैं, ग्रेउंस भी बोलते हैं, ठीक है। सो इसके हम डिटेल में नहीं जाते हैं नेओ। देयर because spurs may be impermeable, permeable, immerged, submerged. So it has a detailed study. So I will give you a little bit overview about these spur dikes. Spur dikes are provided along the rivers to uh, counter the erosion of the banks, because if we do not provide, then definitely the main channel will be change its direction, and it will convert into straight channel, from straight channel to the meandering channel. Okay, so we have to provide these spur dikes to counter the erosion of the river bank. इसके अलावा एक और पर्पस ये होता है कि इट इंक्रीजेस द वाटर डेप्थ इन द मेन चैनल, सो द इट आल्सो गिव्स अ फेवरेबल फॉर द नेविगेशन पर्पसेस। अगर हमारी मेन चैनल, इट इज द मेन चैनल इन द मिड ऑफ दिस चैनल, so here is the main channel. If the water depth is high, then definitely it will be a good for the navigation purpose. So that's why we have to provide spur dikes at different distances. So it depends upon the type of the channel on which you are going to apply, because ये जो spur dikes होते हैं, इनका ये भी होता है कि सिर्फ एक रिवर, एक ही बैंक के नाम प्रोवाइड किए जाते हैं, या फिर ये होता है कि एट डिफरेंट डिस्टेंसेस। सो ये तो उस पर डिपेंड करता है जब हम इसको डिजाइन कर रहे होते हैं। ओके, सो दीज आर नोन एज spur dikes are the greens. So here are the mirroring channels, which are the natural, and here are the braided channels. So it contains small or little islands. इसमें islands होते हैं जो कि with the passage of time change होते रहते हैं. It doesn't, these are not permanent. Okay, so braided channel क्यों होते हैं? Alluvial cells की वजह से होते हैं, और इनमें जो ये जो braided cells है, ये क्या होती है? Consists of a network of the river channels separated with small or often islands. Okay, small or often islands पे होती है, और it is occurs in the rivers with weak banks. ये जो braided channels होते हैं, यहाँ पे जो river होता है, it has very weak banks. तो it is just like meandering के अपनी direction with the passage of time change करता रहता है, और ये जो islands आपको नजर आ रहे हैं, so it and they are not permanent. With the passage of time, यहाँ पे जब erosion हो जाएगी, तो it will also convert from island to water. Okay, so ये अपनी position और location change करता रहता है. So here are the earthen channel design that we will study in next slides, how to design these earthen channel, just like canals. So here are the alluvial soil and non-alluvial soil. The soil which is formed by continuous deposition of silt is known as alluvial soil, because just like river जहाँ पे floods generate होते हैं, especially in hilly areas and in the open land areas, तो वहां पे क्या होता है? जो फ्लड होते हैं, it carries huge amount of the silt in the suspended particles in the form of suspended particles. Where the velocity reduces, that suspended particles will start to accumulate. So जैसे जैसे with the passage of time, जो suspended particles होते हैं, they will start to accumulate at that point where velocity reduces. So from the fertility point of view, they are very fertile and very it has highest productivity with respect to other soils, because इसकी प्रोडक्टिविटी क्यों अच्छी होती है अगर हम इसको कंपेयर करें इस पे, बिकॉज इट इज वेरी इट हैज पोरोसिटी, इसमें जो पार्टिकल्स होते हैं वो कंपैक्टेड नहीं होते हैं. ओके, विद द पैसेज टाइम जैसे जैसे फ्लो या रिवर इन ड्यू टू बिकॉज ऑफ फ्लड जनरेट होता रहता है, तो ये सस्पेंडेड पार्टिकल्स इसके अंदर होते हैं. जहाँ पे वेलोसिटी रिड्यूस होती है वहाँ पे ये पार्टिकल्स कलेक्ट होते रहते हैं. जैसे जैसे कलेक्ट होते जाएंगे तो वहाँ पे क्या हो जाएगा, दैट डेप्थ वी अचीव that will be very fertile as compared to other which is compacted. So अगर हम agriculture point of view से देखें तो alluvial soil is most important for the fertility point of view. It has maximum productivity. Okay, so next one is the non-alluvial soil. Here is the disintegration of the rock formation. It is mostly provided, it is mostly available in the hilly areas, जहाँ पे hilly areas होते हैं. So at that places we have to observe that that type of soil is non-alluvial. और जो वहाँ पे क्या होती है, जो soil disintegration of the rock mean जो rock के छोटे छोटे particles होते हैं that are impermeable particles and not good for the प्रोडक्टिविटी पॉइंट ऑफ व्यू. तो alluvial soil में ये होता है कि नेचुरली उसके ऊपर डिफरेंट क्रॉप्स क्रिएट हो जाती हैं, या फिर इसी सॉइल का जो अगर उस इलाके से होंगे जहाँ पे मोस्टली फ्लड प्लेन एरियाज पे रहते हैं, तो वहाँ पे जब फ्लड आते हैं तो आफ्टर फ्लड वहाँ पे जो जमीन होती है उसमें उसकी जो फर्टिलिटी है दैट एनहांसेस. सो alluvial soil is most important for the fertility point of view, and non-alluvial soil are mostly available in the hilly areas and is not favorable for the productive point of view. So the soil is hard and impermeable in nature. That's why we cannot use for the agriculture point of view. Okay, so here are the alluvial soil and non-alluvial soils. Okay, so here are the introduction of the importance of efficient design. So now we are going to start the design of the channel and which steps we have to follow and which methods we will apply. So first of all, we will study about its background and its importance. First of all, the most important part is the efficiency. So efficiency included the maximum discharge at the outlet. So when we design a channel, so our main priority is that जो हमारी downstream है या outlet of the canal है वहाँ पे क्या हो, maximum discharge achieve हो. So maximum discharge achieve हो, it means that minimum erosion हो for the good efficient channel. Okay. जब भी
Yes,
आप
sir.
कोई भी yes बोले बच्चे.
तो मैं रिस्पॉन्स दे रहा था, आपने बोला ओके, मैंने कहा यस सर.
Okay, so the canal efficiency suffers from silting and scouring. What is silting? What is silting? बोले बच्चे.
Deposition of sediments or deposition of silts.
Yes. And scouring. What is the
Erosion of-
difference between scouring and erosion? What is the difference between scouring and erosion?
स्कावरिंग मेरे ख्याल से लूज सेडिमेंट्स की होती है और जो इरोजन होती है किसी हार्ड रॉक की या
No.
हार्ड स्ट्राटा की.
No. What is the difference between scouring and erosion?
Excuse me, sir.
Yes.
सर डिफरेंस ये है कि स्कॉरिंग जो है वो हमारा जो स्टे वाटर होता है उसकी वजह से होती है, और
Yeah.
एरोजन जो होता है मूविंग वाटर की वजह से होती है हमारी.
So then what is the difference?
मींस के एरोजन के अंदर हमारा जो है अपने साथ उसको लेके जा रहा होता है वाटर, जो मूविंग वाटर होता है अपने साथ लेके जाता है सॉइल को डिफरेंट एरिया से रिमूव करते हुए. अगर इन स्कॉरिंग की वो एक एरिया के अंदर हमारा वाटर खड़ा होता है और उसी की वजह से
So
जब सॉइल के अंदर वो करता है, पेनिट्रेट करता है, तो उसकी वजह से वो अपने साथ थोड़ा सा डिपॉजिट को रिमूव करना शुरू कर देता है, सॉइल को।
No. Any other student, what is the difference between scouring and erosion? आपकी बात कुछ हद तक है, लेकिन it's not a right answer. So there is a major, a big difference between scouring and erosion. Yes.
इरोजन जो है वो एक वाइड एरिया पे अकर होती है, और जो स्कोरिंग है वो लोकलाइज्ड किस्म की होती है।
With respect to area बोल रहे हैं, okay,
Yes, sir.
scouring and erosion, अच्छा, okay. कोई other student, मीन कि आप थोड़ा बहुत हल्का फुल्का कह लें, it's okay, but it's the major difference between scouring and erosion. You have to know about the what is scouring and what erosion. Okay, कोई other student?
सर स्कॉरिंग होती है मूविंग वाटर की वजह से, और इरोजन हो
Okay.
सकती है वो विंड की वजह से भी हो सकती है, और काफी सारे फैक्टर्स उसके और भी हो सकते हैं इरोजन के।
ओके, मुझे जो स्कावरिंग होती है ना, यहाँ पे जो दो स्पार डाइक के दरमियान द डिफरेंस, द डिस्टेंस बिटवीन टू स्पार डाइक्स इज द स्पार डाइक फील्ड, ओके, फ्रॉम दिस पॉइंट टू दिस पॉइंट, ओके, इट इज नोन एज स्पार डाइक फील्ड. सो हियर what you think about here, there should be erosion or scouring?
Scoring, sir.
Yes.
Scoring,
Okay. Why not? Yes, definitely scouring. So why you are not saying that it's erosion? Because here also water moves and also changes this distance from this point to this point, and also take this scouring particles away from this location. So why you are not saying erosion?
Sir, velocity of moving water is the reason.
No.
Or depth of water.
Velocity, distance, depth are not the reasons. बच्चे जो scouring होती है, it's the along, just like this you are saying that it is scouring, okay, well and good. यहाँ पे जो along the bank हो रही है, it's scouring, that particles move along, may move. It's not necessary that it always move, because with the passage of time, यहाँ पे अगर downstream of spar dike देखें तो यहाँ पे velocity क्या हो जाती है, reduce हो जाती है upstream से downstream. When it moves from upstream to downstream, then it velocity will reduce, especially in this spar dike field. जब velocity reduce होती है तो the suspended particles will start to collect in the spar dike field. With the passage of time, a huge amount of silt accumulation we have observed. अगर आप देखें तो जो rivers होते हैं, उनके अगर वहां पे spar dike लगा हो तो there will be a huge amount of silt accumulation at the downstream side. So the silt accumulation, the reason behind silt accumulation is the low velocity in the at the downstream of the spar dike. When there is a low velocity, then definitely the suspended particle will start to accumulate in the spar dike field. Okay, and we also can see that after a huge time, this spar dike field will be filled with silt. Okay, so it is not necessary to, and there will be always erosion. Sometime there will be a silt deposition, और मैंने इसकी रीजन भी बता दिया, why there is a silt deposition between two spar dikes are in the spar dike field. Okay, so come to the point that the difference between erosion and scouring is due to the along the bank, और erosion ये होती है कि it washes some specific depth of the whole area. Okay, just like अगर आप पियर ऑफ द ब्रिज देखें, पियर ऑफ द ब्रिज, ठीक है ना, उसमें क्या होती है, इरोजन होती है, वहां पे स्कावरिंग नहीं होती. इरोजन मीन it removes some specific, for example 2 इंच या 3 इंच की जो डेप्थ होती है, it flashes away, it flush away. मीन के 2 या 3 इंच की जो डेप्थ है सैंड की या सॉइल की, ये अपने साथ पूरी जो बेड के साथ होती है, पूरे बेड में से रिमूव कर जाती है, वो होती है इरोजन. और जो स्कावरिंग होती है वो बैंक के कुछ पार्ट में से थोड़ी थोड़ी करके इसको रिमूव करती रहती है. लेकिन जो इरोजन होगी इट विल फ्लश द टोटल डेप्थ और इट विल मेक चेंजेस फॉर द होल ग्राउंड, ठीक है। मीन के जो रिवर बेड है वहां पे क्या होती है, इरोजन होती है। वहां पे जो चैनल की डेप्थ है या चैनल का जो बेड है उसमें से जितनी भी डेप्थ में से जो मूवमेंट होगी सॉइल की या सॉइल पार्टिकल्स की, जो भी टाइप ऑफ द बेड ऑफ मटेरियल होगा, इट मे बी सम लार्जर पार्टिकल्स, ओके। सो वहां पे जो पूरे बेड में से क्या होगी, particles की movement होगी, that will be the erosion, and covering will be the some specific part just like along the bank of the river, okay। कुछ समय लगी इरोजन और स्कवरिंग की। स्कवरिंग, the example for the scouring is just like क्या कहते हैं उसको, पियर ऑफ द ब्रिज। जो पियर ऑफ द ब्रिज होती है उसकी स्कवरिंग होती है, क्यों? क्योंकि पियर के अराउंड भी और उसके अलोंग भी जो particles होते हैं also moves from upstream to downstream, that are the erosion, and here is the scouring। scouring mean कि जो पियर होता है इसके अराउंड काफी ज्यादा होल क्रिएट होता है, उसके अगर जस्ट उसके अराउंड देखें पियर के, दैट इज scouring। अगर ओवरऑल देखें, ओवरऑल मीन के at some distance around the pier, then that will be the erosion, that will be the erosion, and specifically pier के around scouring।
Yes, sir, clear.
Okay, the other problem whose origin lies in the faulty design are weed growth infection, heavy seepage losses resulting in water logging alongside the canal. So you are well familiar with these weed growth infection. When we design the canal, then we have to consider these negative points, that if we make a lining canal, अगर आप canal में देखें, if it is lined or unlined, अगर वो उसकी lining हो चुकी है, then definitely we have also observed some weed growth, जो उसमें जड़ी बूटियां उसमें हो जाती हैं, then that due to that weeds, it will be a negative point because it will create it will infect our structure, okay। So it causes instability of the line of that structure, either it is the canal or any other structure। So weed growth is the most important point for the design of the canal or any channel। And the next is the deficiency is the heavy seepage losses. If our canal is unlined, then definitely there will be a seepage that due to this seepage, the water table rises. Then if the water table rises, then what will happen? Well, what will happen if the water table rises? Because mostly we observe in specifically if we talk about Pakistan, then the most canals are not in line, so unlined structures, जिसको हम कच्ची canal भी बोलते हैं, so they are not lined। So we have to face that problems, in which the most important problem is the rises of the water table and the seepage losses। मीन के हमारा पानी भी ज़ाया हो जाता है और उसकी वजह से जो वाटर टेबल है ऑफ द अराउंड एरियाज, द वाटर टेबल आल्सो राइजेस। सो व्हाट विल बी द इफेक्ट इफ द वाटर टेबल राइजेस, व्हाट विल
सर वाटर लॉगिंग हो जाती
बोले
है।
अपलिफ्ट
व्हाट इज व्हाट नो
सर
नहीं वो
वाटर जो है ना
ठीक
वो
है,
सरफेस पे,
ठीक है, बोले
सर वाटर जो है ना सराउंडिंग एरियाज में सरफेस के ऊपर अफेयर हो जाएगा, जिसकी वजह से सर मतलब सॉइल सारी खराब हो जाएगी, मतलब एग्रीकल्चर वगैरह के लिए भी नहीं सही रहेगी वो सॉइल।
तो क्या हो जाएगा, उसको क्या बोलते हैं हम?
सर वाटर लॉगिंग।
ओके ओके ठीक है। तो उसको काउंटर करने के लिए कोई क्या करते हैं हम? अगर आप बिलोंग करते हैं उसी मीन के एग्रीकल्चर एरिया से, इफ यू आर वेल फेमिलियर विद दैट प्रॉब्लम, देन हाउ टू टैकल दैट इशू? उसमें हम क्या
सर
करते हैं?
किनाल
वाटर लॉगिंग।
लाइनिंग कर देते हैं।
सर यूजली हम जो होता है ना सफेदे का दरख्त लगाते हैं उसके लाइनिंग के ऊपर ना, जो देहात में अक्सर चलता है, तो उसकी लाइनिंग के ऊपर सफेदे का दरख्त लगाए थे जिससे पानी जो है इवेपोरेट होता रहता है इस तरह के एरियाज।
डेफिनेटली तो हम इसको then we have to counter these problems because if the water table rises in that areas, then at specific limit, then definitely that areas will be not suitable for the agriculture point of view. So we are providing these canals to increase the agriculture ratio so that people can take the water at their destination. So our main purpose is to provide the water at the agricultural lands. If the water logging occurs at that areas, then definitely it's not suitable for the agriculture point of view. So we have make maximum effort to line that canals, so that there will be a minimum loss of water. Evaporation is the natural phenomena. Anyhow, the other phenomena just like seepage or water logging will be minimum if the canals are lined canals. So other importance are the canal design also depends on the conditions, particularly soil formation, sediment transport, operational needs, and desired standards of the maintenance. If you design some specific, for example, if you design a canal, then if you haven't provide enough slope from up to down, then definitely it will be a great loss because the water cannot move accurately from upstream to downstream. Then with the passage of time, the silt accumulation will start at the depressions point or the low level of the bed. So we have to make some maintenance techniques. It's better कि हम maintenance we would not provide any maintenance technique, but we also provide the efficient design of the canal so that we do not provide any maintenance. Maintenance mean if your design is not good that the water cannot move upstream to downstream, or it start to collect the suspended particles, then definitely the bed of the canal will start to accumulate with the silt. Okay, so we have to remove that silt. If you not remove the silt, then definitely the bed will start to destroy, disintegrate, and mean के जो channel है, it will have definitely there will be a great loss for the water, because if the channel is full of sand or suspended particles or any accumulation, it may be soil or any other type of the material, then how your channel is efficient कि outlet के ऊपर कितना आप discharge achieve कर सकते हैं, then definitely the amount of discharge will reduces or minimum at the outlet, while our canal will be efficient if you get the maximum discharge at the outlet. So during design of the canal, you have to consider these factors that the operational needs minimum, जो हमें maintenance techniques and there should be minimum and they must be provided. ये नहीं है कि हम maintenance techniques provide ही नहीं करेंगे, ये होती रहती हैं after a year, after 2 years we have to clean the whole channel with the passage of time में, बट ये नहीं है कि हम हर 2 माह 3 माह के बाद उसके अंदर ऑपरेशनल टेक्निक्स के लिए पहुंच जाए, तो there will be a great loss for us. So the solution will be
Excuse me, sir. Sir, you are not audible. So kindly
ओहो,
please
सर का
check
माइक बंद है यार.
Okay.
रिलैक्स.
अच्छा, आप यहाँ मौजूद हो?
यार क्यों मुझे पहली क्लास में मार पड़वाते हो?
जरा खामोश रहो यार, थोड़ा थोड़ा ना, आप ज्यादा ना बोलो.
ओके
Hello, can you hear me?
Yes, sir.
Yes, sir.
हाँ जी सर।
ये माइक किसने बंद किया था?
सर मेरे लगा आपने खुद की है।
मैंने खुद कैसे किया है? क्लास के दौरान मैंने उसको ओपन ही नहीं किया तो कैसे बंद हो गया? इशरातें बंद किया करें मुझे।
ये कीबोर्ड से भी हो जाता है।
क्या चीज?
ये कीबोर्ड से कोई म्यूट का बटन जब प्रेस हो गया होगा आपसे।
मीन के आप मेरे सर पे डाल रहे हैं ना कि मैंने किया है? मैंने नहीं किया वैसे।
नहीं सर,
आपने आपने कोई उस्तादी जो है ना वो की है, और रहने दे जिसने भी किया है, ठीक है? ओके।
सर यहाँ ऑप्शन होता है फुल कंट्रोल करना, तो अगर कोई इस तरह से कर रहा है तो आप फुल कंट्रोल का ऑप्शन ले लें। उसके अंदर आपके पास यहाँ पे माइक्रोसॉफ्ट टीम में ऑप्शन होता है जिसके वजह से कोई नहीं कर सकता किसी को म्यूट या अनम्यूट।
अच्छा ठीक है। अब बच्चे तो नहीं है यार, आप फाइनल ईयर के स्टूडेंट, आप क्लास सेमेस्टर है, तो आप अगर इस तरह की हरकत करते हैं तो ये आपको सूट नहीं करती। ओके। सो अब छोटे बच्चे नहीं है कि आप के लिए हम मतलब कि मैं वो करूँ या ये करूँ। एनी हो, जिसने किया उसको शर्म करनी चाहिए, किया स्टूडेंट ने है। ओके। सो हियर आर द सम टेक्निक्स आर सम इम्पोर्टेंट पॉइंट्स. Now we will. There are two types of the canal, either it is online and line. We are studied about in detail about online structure. अगर online channel होगी, then what will the problems we have to face? And if it is line channel, then definitely we will observe minimum problem. So line may be RC, PCC, brickstones, etc. to minimize the seepage loss, then increase the efficiency of the system. Okay, so line channels are the most important channels and most commonly used. And in the Pakistan nowadays, because of the जब हमें water shortage, we observe that there is a water shortage. So definitely we will start to line the online channels. जब हमने देखा कि हमारे पास जो पानी की स्टोरेज है वो कम होती जा रही है, और उसकी वजह से पहले तो हम यही था कि हमारे पास जितने भी चैनल्स थे वो ऑनलाइन ही थे, लेकिन विद द पैसेज टाइम व्हेन वी ऑब्जर्व a lot of problems, then we start to line that channels with the different material, that either it is RCC, PCC, bricks and stones. Okay, so maximum nowadays maximum irrigation canals are line channels. So factors affecting the design of the canal, there are two factors, that is main factors and the some minor factors. That is the main factors of the water discharge. Okay. Water discharge is the main factor that you have to consider during your design of the canal. Next one is the sediment discharge. Okay, so you have to design such type of canal that the discharge of the sediment should also be maximum. If you observe that when we take canal from the barrage or from any river also collect on the barrage. So you have also the silt excluder, silt ejector also provided when you are taking canal from that river. So the purpose behind these silt ejector and silt excluder is that कि वहाँ पे जो silt accumulation or in the form of suspended particles, it will be its magnitude or its volume should be minimum. So we have to provide these structures, that is silt excluder and ejector. Here the next part is the sediment size and the slope of the canal bed width and depth and the velocity. Next one are the minor factors, that is acceleration due to gravity, shear stresses, and the viscosity, temperature, and the sediment density. So here are the main and major and the minor factors that will affect your canal design. Okay, so here are the design of the irrigation canal. It is the process to obtain a cross-section slope and geometry of the channels canal, which should not have objectionable silting and scouring. So when you are designing a canal, there should not be silting, there should not be scouring. Mean के maximum discharge भी ना हो, minimum discharge भी ना हो. So you have to if your discharge is minimum, then definitely the chances of silt accumulation will be maximum. And if the discharge is maximum, if you provide a huge amount of slope from upstream to downstream, then the maximum chances for the covering. And if covering occurs, then the failure of the channel will be also occur. So you have to design optimum or efficient canal for the if you want to avoid the silting and covering problems. So here are the determinings of canal that are the depth, bed width, side slope, and the longitudinal slope of the channel. What do you think about the longitudinal slope of the channel? What is this longitudinal slope of the channel?
Along the length of the slope.
Along the flow
length,
of water.
sir.
Okay, so yes, बोले मुझे.
तो फ्लो ऑफ वाटर की डायरेक्शन में जो फ्लो होती है आपकी.
Okay, so it should be said that it should be not non-silting and non-scooping. Okay, velocity for the given discharge and sediment load. So you have to consider these functions of the depth, width, side slopes, and longitudinal slope. Here are the approaches to use the design for the earthen channel that are empirical, semi-empirical, and the rational. So today we will study about the empiricals, and in the next slides or in the next lecture there will be semi and the rational. The empirical approaches are totally basics on the approaches which are provided the mean regime depends upon the regime theories. What are the regime theories? Mean जितने भी साइंटिस्ट थे उन्होंने अपने एक्सपीरियंस और अपने बिहाफ पे जो अप्रोचेस प्रोवाइड किए हैं, दैट इज if you provide these factors, then the scoring and silting phenomena will be minimum. So empirical approaches will be different for the different scientists or the designers. So these methods are based on the canals which were working reasonably well, and they were not having any objectable silting and scouring and having the stable cross sections. So they have provided their theories, and the results are well and good. There is no scouring, there is no silting. So that's why they provide a theoretical background that if you do such parameters, if you take these parameters, then definitely you will also have you will also not face these silting and scoring problems. Anyhow, these theoretical background will be not applicable for all areas. So there will also have some drawdowns. So we will study about in detail in the next 2 to 3 theories. These channels were fulfilling the requirements to carry design water and silt discharge. They are working well and good, mean there is no silting, there is no scouring, and obtain a maximum discharge at the outlet, and they are efficient. So these are not dimensionally homogeneous and do not follow any law or theory. So because any जो भी scientist है वो अपनी तरफ से एक theory दे देता है, so that or does not any follow theoretical part or any laws. So we cannot rely on these theories. If you anyhow you can take that knowledge to improve their abilities or skills, that how he achieved it in this conclusion. So you can take that knowledge but cannot implement that knowledge into your design. So here are the stable channel definition is said to be state of regime if the flow is such that silting and scouring is not special tension. There is no, if there is no problems in with respect to scouring and siltation, then that channel are known as stable channel. Okay. So here are the theories of Lane 1919 and Lane, that is 1953. What's a Lane? Lane is when an artificial channel is constructed in alluvium to carry silty water, its bed and banks would silt scour until the depth. Okay, slope and width attain a state of balance to which the design as canal in regime. So he explained about the stable channel or the regime, and the next is the lane, that is 1953. He says that stable channel which carries water, the banks and bed of which are not scoured objectively, being objectionable, mean के उसमें कोई objection नहीं है, then that channel or the stable channel by moving water, if water is moved from upstream to downstream. If there is no rejectionable deposit of the sediment, then that channel are known as the stable channel. Here is the Kennedy's regime theory, the most important theoretical in the design of the earthen channel. So first of all, he was execution engineer in the upper Braided channel in the Uttar Pradesh, that is Indian. He's an Indian researcher. So published his work in 1895. His research was published in 1895, and here are some conclusions about his 20 different sites on the observations. उसने 20 different sites के ऊपर observation किया, and then he made some conclusions of his research. The conclusions of his research are: the water is counteract against the friction from the bed of the channel, resulting in geometrical vertical eddies. What is the eddies? What do you think about what are the eddies or recirculation regions? eddies क्या होती हैं?
Sir, whenever there is a conversion of from
Conversion.
Sir, can you hear me?
Yes, I can hear you.
Yes, sir. I was saying that whenever there is a conversion of the streamline flow into a turbulent flow, so there is a formation of eddies at that particular regions. So they are harmful because they result in the erosion and such kind of activities.
Yes, definitely. So where these are generated?
So usually where there is a change in cross section, just as in case we have a hump, and whenever we experience a brink there, so there are chances that such kind of things happen, and also as in case of a converging channel or diverging channel.
Yes, okay. So according to his research work, he concluded that the vertical eddies also generated that contract against the friction from the bed of the channel. The next conclusion is the velocity is sufficient to generate these eddies keeps the sediment in suspension. It doesn't allow the suspended particles to be deposited at the bed of the channel. So these eddies are avoiding the silting of the channel on the bed, not scouring and not silting. His next conclusion is say velocity against erosion of the canal in Punjab style is 1 meter per second, corresponding to the depth of not more than 3 meters. So if he says that if the channel depth is 3 meters, then if the velocity should be 1 meter per second, then there will be not erosion and not deposition. So here these are his assumptions. We cannot say that these assumptions can also be implemented in our canal structure. So the next one is the amount of the silt held in suspension is proportional to the upward acting force of vertical eddies and varies as bed width and some power of the velocity of the flow in the channel. The next one is the regime channel is one which neither silts are not covered. What is the regime channel? Regime channel also are the stable channels. We have also studied its theoretical background that in the previous slide, that the stable channels are the channels which does not allow the scouring and silt deposition. So regime channel is one which neither silt are not covered. He also gives Manning's roughness that is 0.0225 for all irrigation channels. So in the next lecture we will study about its the equation and how much modifications were made in its general equation that we may also use in our canal design. ठीक है, तो हम इसको नेक्स्ट लेक्चर में देखेंगे इसके जो पार्ट हैं, और we also studied about some numerical problems and in its derivation. Okay, so end of the lecture for today's lecture. So if you have any question from the today's lecture, you may ask. Otherwise, see you in next class, inshallah. Student, if you have any question, you may ask.
No, sir. Thank you so much.
Okay, so in the next class we will derive its relation and its drawbacks and that how either we should use or not. So okay, see you next class, inshallah. Allah Hafiz.
इंशाल्लाह सर, अल्लाह
अल्लाह
हाफिज।
हाफिज़।